We are looking to solve this quadratic equation, and we are told to use any method. So looking at this, I want to kind of be strategic about what method I pick based on the type of equation I have. So first off, it's in standard form. It's set equal to 0. That's great. I don't have to do really a lot of movement. What I'm noticing is that I have a single x squared, and then I have an even bx. So right away, what I'm thinking is complete the square. This is going to be the most efficient way because completing the square begins with starting with a single x squared and then building around it my bx term, splitting that in half. So if this is even, I got one of those. This is great. That's what I want to do. So the first thing I want to do is I want to isolate my x terms. I kind of want these pieces by themselves. So I will subtract 15 from both sides. Subtract 15. And that's going to leave me with x squared plus 6x. And I'm going to leave a little bit of space here because when I complete this square, I'm going to end up adding a number to both sides. This is going to become a minus 15. So really what we want to do when we complete the square is we're going to figure out this number, and it's typically called c because once we do this, that'll be your ax squared term, your bx plus your c. You know, there's another number over there. It's the b value divided by 2, and then you square that number, right? And that's why having an even b here is really nice. The other thing we can do is we can think about this sort of visually with what's happening. I build with a single x squared. That's part of the reason I want 1x squared. And then I'm trying to create a square. I'm going to take half of these terms, again, that's why even is nice, and split them up so that I create the same amount of distance going both up and to the right. Then that begs the question, what needs to go in this location in order to complete the square? Well, let's think about this in terms of an area model. Well, in terms of an area model, this would be x times x, and then a 3 here, right? X times 3 is 3x. 3 here. So the number that I need to complete the square is 3 times 3, which is 9, right? It's always half of this number, 3, times itself squared. It's 9. So I add 9 to both sides. The whole point of me doing that is to create a binomial square, to create a perfect square. And that's what goes in the parentheses is always what's on the outside of the little square that I've created, x plus 3. It's always x plus or minus if it's negative. Half of b. It's this number cut in half. It's the half of b part. And then over here, let's see, negative 15 plus 9. That's going to give me a negative 6, I believe. We'll put it in the calculator just to be sure. So that's a negative 6. And I'm going to just rewrite this line exactly the same. But I just want to be very clear what I'm doing to solve this. I'm now at a point where I can solve using square roots. So I take the square root of the left, and I do the square root of the right. Because I am introducing the square root, it's going to have this plus or minus symbol on it. This is canceled over here on the left side. That's what I wanted to do to try to isolate x. I needed to get it out of that square. Plus or minus square root of negative 6. So that's negative 1 times 6. And the reason that I'm doing that is I want to break this up to an imaginary component. We used to stop and just say there's no real solutions, but now we can actually put the answers as a complex or an imaginary solution. And we do that here by making this negative 1, and that's square root of 6. And it's one thing that we need to kind of always keep in mind is that the square root of negative 1 is our imaginary number. So that's really important. Anytime we get a square root under the negative, we're going to replace it with I. So this right here, it's going to become I. It's kind of a light color. I'll darken that up a little bit. It's an italicized I. So we get x plus 3 equals, now we still have the plus or minus. This became I. This is the square root of 6. 6 is not a rational number that can be simplified. If we start thinking about our perfect squares, 0, 1, 4, 9, right? We've already passed 6. There's not a perfect square that goes into 6. So all I need to do from here is subtract 3 from both sides. And this is not a like term with anything on the right side of the equation, so it's just going to become negative 3 plus or minus, and I typically will put my imaginary number after. If you left it in front, that's totally fine. In fact, I'll write it both ways. You can put the I here. I like it on the outside. It's up to you how you write your final answer. They're both correct, but that's where we want to end up. So this equation, if we graphed it, if we replace that y with a, or 0 with a y, this would not have any x-intercepts because our solutions are complex. They have an imaginary component. Okay, hope this is helpful. Message me anytime in Zoom.